Today we are going to start with our new topic. The topic is earthquakes. What is an earthquake? In simple terms, whenever I talk about earthquake, students they always say that earthquake means plate tectonics. Earthquake doesn't mean plate tectonics. Earthquake is related to plate tectonics. Plate tectonics is one of the major reasons for happening an earthquake. By saying that there are number of reasons by which an earthquake happen, and one of the major reason is plate tectonics. So earthquake is not plate tectonics. Plate tectonics is completely different theory what we discussed yesterday. That is the movement of plates over the asthenosphere by the process of different forces. And while moving this kind of plates, these plates will come and collide, and where it accumulates stress, and at a point this stress releases, the point where the stress releases by either breaking the rock or by adjusting the location of the rock. So this sudden release of energy which shakes the surface is called an earthquake. Okay. So there are number of other reasons. Landslides can create earthquake. When you have a huge amount of land which is moving down and it fall down, and that landslide can create earthquake. There are earthquakes which are created by dams. Seismicity or earthquake induced by dam, Koina Dam is a very good example. So the point is that earthquake is not tectonics. Tectonic is a reason for earthquake, and there are number of other reasons by which earthquake can create. But what is an earthquake? Earthquake is a vibration induced in the ground due to internal or external forces. Okay, it's a vibration induced on the surface due to internal or external forces that virtually shake up a part of the crust. When the crust shakes, it will shake up all the structures of living and non-living things existing on the surface. So that process is a sudden process of release of energy by shaking the ground or the crust. We call it as a earthquake. So this figure what you see on the screen, which generalize the process, there is a rod which is going on, and there is forces which are accumulating on this block of rock. Okay, these forces which are accumulating, for example, let us take it is an earth. It is a tectonic forces because of the movement of the plates that we discussed yesterday. So this movement of the plates which acting on this. So this initially these rocks will slightly modify. This we call it as an elastic deformation. And if you remove the forces, it may come back. One point this process will exceed the strength of the rock, and it will break the rock. So this breaking of the rock, what will happen? All this energy which accumulating on this these rocks for a period of hundreds of years will be releasing in a very quick way. So that release of energy is called a earthquake. And there are number of small releases before and after a major earthquake. We call it as a pre-shocks and aftershocks. Okay, so the shocks or the small minor earthquakes we generating before the breaking of a major breaking or after the breaking of a earthquake, there are records of that. So that actually the processes which adjust. This is the condition, and I'm comparing it with, you are having a small stick in your hand, and now what I'm doing is that I'm trying to bend that stick. The same thing what happens on the surface or the layer or the lithosphere also. When I'm trying to bend this, it is bending, and you can imagine that when you bend it, when you increases the forces slowly, you may not feel any changes on your hand. But at the point when you break, what happens at the point when you break this stick? But at the point when it breaks, you are not able to keep your hand steady, because the energy which was accumulating on the stick is releasing in a very fraction of second. For 2-3 minutes you are bending slowly, so it took 3 minutes to accumulate the force, but it took only fraction of seconds to release that. So that time you are not able to keep your hand stable. So as a result, it will shake that process. So it happens here is what is the earthquake event. Okay, after the earthquake event, we can keep our hands stable. We can keep our hands steady, but it would be in a different location, like what it is happening here. Here, if you see, there is a river which was flowing that shifted its path, Okay, so there is a river which was coming, it shifted its path. So this kind of surface features will help us to identify then in what period this earthquake happened. Okay, so there are instrumental records that the seismometers and all records the earthquakes on these days, but the earthquakes on the past days, because when I'm going to construct a nuclear power plant, I need to have at least for the last 100 of years earthquake history. So we don't have a record of seismographs which records the last 100 years earthquake history of that location. So what we'll get is some kind of surface features that is basically a geologist will be able to understand, and they will be able to date in what event which happens and this much amount of change which happened. Then what would be the energy released, or accordingly they calculate the magnitude of that earthquake. So that kind of things will be done by a geologist. Correct. So this is how an earthquake happened, and if you need to understand in little bit more clear way, so imagine this is a lake, large lake. So I am holding the same stick, and right now I am under the water. So this is the water surface, and I am under the water. Now here I am trying to bend that stick. Okay. So at a point the stick will break. What happens? I'll shake my hand. This shakings will create what? It will create the waves. Now, what is this? The line showing? This line showing these are the shake, the energy which released by me under the water, and it created waves on the water, so that waves will travel towards the surface of the lake. Okay, fine. So this waves which is traveling towards the surface of the waves, which will come to the surface. After reaching the surface, what will happen to these waves? What will happen to these waves? These waves will move on the surface of the earth, so surface of that lake. So this is almost the same thing happens during an earthquake. Correct? So the rock, instead of the stick what I'm holding now, below the surface what happened, this is a rock. The rock is accumulating the forces and it breaks. While breaking, it releases energy. That release of energy will be in the form of pulses or in the form of waves that travels towards the surface. It reaches the surface. Some amount of these waves will escape to the atmosphere, and some amount of the waves will travel through the atmosphere by creating waves. So the surface we will be seeing waves moving in all directions. Okay, so this we call it as two type of waves. One, it is the waves which is traveling through the body of the earth, we call it as body waves. Okay, and the second one which moves over the surface, we call it as surface waves. So we'll see these waves one by one. What is this wave and how it propagates and why we call it as different variety of waves. So body waves means which is the waves which is originating from the rupture to moving towards the surface of waves. So these waves we classify further into two categories. These two categories are primary waves and the secondary waves. Okay, primary waves and the secondary waves. And if you see the propagation of these waves, the primary waves are like expansion and compression. Okay, it moves like sound waves. You know that how sound waves moves. There would be a compression, then there will be an expansion, then compression, then expansion. Similarly, the primary waves also moves like a compression and expansion. Okay, so if you see that the movement of the particle in these primary waves, that is parallel to the direction of the propagation of the wave. Whereas in the case of secondary waves, the movement of particle is perpendicular to the direction of propagation of the wave. For example, if I tie a rope in one end and create a wave here, so you can see that the wave propagates on this rope and reaching the end. So here what happened? The wave propagates, but the direction of movement of material is perpendicular to the direction of propagation of the wave. Okay, so these are the two different varieties of body waves, which are primary waves and the secondary waves. And one important aspect it is expected to note here, the primary waves moves almost double the speed of a secondary wave. Okay, so this moves, yesterday also we have seen, we discussed that the primary waves, if it is moving around 5 to 8 kilometer per second, is the speed of primary waves, whereas the secondary waves, which moves around 3 to 4 kilometers per second. Okay, so that is one of the important factor we have to note down here. And the second thing we have to note down here, the primary waves or the P waves, which can travel through all different media, if it is solid, liquid or air. But in the case of secondary waves, it can only transfer through solid media. Okay, so the waves which are originating from the rupture of a rock, we classify it into body waves, and these body waves are of two types, which are primary waves and the secondary waves. Now, when these waves move from here and it's reached the surface, once it reaches the surface, some portion of the primary waves will escape to the atmosphere, because the waves can travel through atmosphere also. So the body waves, some portion which the waves which is escaping to the atmosphere, rest of the waves will move all along this body of our earth. So then we call this waves as surface waves, and the surface waves are one of the important concern for a civil engineer, because the surface waves are the waves which damages our buildings or in our constructions. And what is the surface waves? How is it propagating? It propagates in two different ways, or we call it as two different wave types. One is a Rayleigh wave and another one is love waves. Love waves, which produces a side by side motion, and the Rayleigh waves, which produces a circular motion. But both the waves move together, and in the case of Rayleigh waves, it moves like a circular motion, and the same time the things will be moving in a side by side motion also. Okay, so these are the two different varieties of waves in the case of surface waves. So now to move ahead with some other basics about our earthquake. As I said, there are there are location which is the surface or the point below the surface of the earth where the rock breaks and the earthquake originates. So that point where the rock breaks, that is called a focus or a hypocenter. Okay, so this is a rock layer. So this is the point which is the point below the surface of the earth where an earthquake originates. That point is called focus or hypocenter. But whenever there is a point which earthquake which originates below the surface, there is an imaginary point on the surface of the earth which is directly above the focus. That point is called epicenter. The people who study this earthquake waves, okay, and to get information. So, as I said, that the earthquake is one of the major important source of information to collect about most of our subsurface details. Okay, so this seismology is the branch they study. Seismology is the branch we study about this earthquake and its waves. So, okay, so these evidences are used to interpret the characteristics of the rock types which is below the surface, and some amount of information like the different layers of earth, the properties of these different layers of earth. This all comes from the study that is called a seismology. And here you have seen one more term, which is a fault. Fault is nothing but it is the breaking of the rock. Okay, here it is visible in the surface, but if the breaking is happening in subsurface, usually sometimes you may not be able to see this break, but still there would be some amount of displacement in the broken rocks. Now, if you go that, what is the importance of a civil engineer to understand this these earthquakes? Because when you have to ascertain the factors that lead to earthquake tremor is one of the important thing we should understand, because if there is an earthquake, the structure is going to disturb. So what kind of factors which tremor which give rise to the generation of earthquake. Like we discussed yesterday, the storage of water in a reservoir can lead to earthquake. Okay, so while designing a reservoir location, identifying a reservation location, we should actually see that what is the characteristics of rock types in that region, and constructing a reservoir will be triggering an earthquake in this region or not. So that will need to see that to predict the occurrence of an earthquake, that which are the areas where chances of earthquakes are high. Okay, for example, if I'm taking the Indian subcontinent, if you go to the southern part of our India, which considered to be stable in earthquake, because that is a very old rock type formed which around 5 billion years before. So, sorry, 3 billion years old rock types what you are getting. So that are considered to be the stable portion. But when you are in the Gujarat and when you are going to Himalayan regions, and if you are going for a construction, then that region is considered to be very prone to earthquake activity. Yes. And finally, then understanding of these two things, that what triggers the earthquake and whether the area is going to be affected by an earthquake. What a civil engineer can do is to design the building in such a way that it resists the failure during an earthquake, and as a result, it will save the human life. Okay, so this is what ultimately a civil engineer needs to do. Okay, so by having this knowledge that where does it can occur, how it propagates, and what kind of damages it can happen. Now, one thing is very important for us, that measuring the seismic waves. Okay, so measuring the seismic waves are done by an instrument, and that instrument is called seismograph. Seismic means it is related to the event, and the seismograph is the instrument what we use in the measuring the earthquake waves or the seismic waves. And when you measure these earthquake waves, what we create is a graph. So that graph produced by the seismograph is called a seismogram. And this instrument, if you see, is a very simple instrument. What it does, when there is any vibration on the surface of the earth, we can divide that vibration into three categories. Okay, one is the forward and backward direction, another is left to right direction, third one is up and down direction. So X, Y, and Z coordinates. So there is a very simple instrument. This is the old analog in seismographs. If you see, there are three components in the seismograph. Okay, so these three components will be measuring the vibration of earthquakes. So what is this? For example, if I need to identify the vibration of this ground in XY direction, then I need to align the instrument in this way. Okay, and this is a simple rolling paper, and here this is a freely suspended pen. Okay, so when there is no movement on the surface of the earth, the pen will make a very straight line on this paper. But when there is a vibration on this XY plane, what will happen to this pendulum? This pendulum will move forward and backward. As a result, it will create a vibration. So what it is identifying, that there is an XY plane direction movement, then that will be recorded in this map, this paper. Okay, and if I need to identify the similarly in the Y direction, this is, for example, if I'm taking it is X direction, then keep the instrument in the opposite way. Rotate the instrument 90 degrees, so we'll get the Y direction. Now we need one more thing, that is the Z direction. What is the movement of surface on up-down motion? So for that, this is the arrangement what we do. This is a freely suspended pen. Okay, so this is the paper roll which is rotating continuously, and when there is a vibration on Z direction, so this paper will show a up-down movement. And this instrument what I'm showing is a very simple instrument. It is to use in the older days, but in today's days, we are not using any such analog instruments. Mostly our locations where we are measuring the earthquakes are done by electronics equipment, so which measures the direction. Here in the screen, what you see is a seismogram. Okay, what you see is a seismogram. What you see here in this different colors, this is one color, okay, this is another color, and this is third color. Three different colors, what you see is the three different directions of vibrations, X, Y, and Z. Now, if you see this line, this red line, which comes out to be very straight, okay, at one point what it reaches, it started moving up and down. What is this point? This point is where there is an earthquake. So these three details represents one station. One station means, for example, in Gujarat, these three stations, it is in Vadodara. Second represents three locations which is there in Ahmedabad. Third represents three stations which is in Porbandar. Something like that. So the screen in total we are seeing around 10-15 stations. Okay, so each three layers represents one station. So this is an online seismic data of Gujarat. That means it is there in a location in Gujarat. These seismic stations are placed, and all these seismic stations are connected via internet. And then one location in Gandhinagar, we are able to see all the vibrations happening on these points on a single screen. So one single screen, we are seeing right now at least 30-40 locations which is there in the Gujarat. Okay, so whenever there is an earthquake happens, so all these locations will get the seismic waves recorded on their station. And immediately now we will analyze that what is the energy which released, where it happens. That things will come down in the next slides. But this is where we will get a evidence or the information of day-to-day earthquakes which are happening on the on Gujarat. Okay, so when there is an earthquake, okay, there are energy release. But while energy releases, for example, if I take an example, what you see here, it is a light. Okay, so I'm going to switch on the light. Now what happens to the light comes, and what is the capacity of the bulb? For example, if I assume it is 100 watt, 100 watt is the capacity of the bulb. But what happens, the intensity of light which is towards the bulb will be high, but if you move away from the light, what happens, the intensity reduces. So this way, similar way, earthquake also have two parameters, which one is called intensity and another one is called magnitude. What is the magnitude? Magnitude is the maximum amount of energy released by the earthquake. That would be a one single point. For example, if this case, if the light is 100 watt, if I am looking at standing here, or if I am standing at 100 kilometer away, and if I am saying that what is the magnitude, what is the capacity of the bulb, that is 100 watt. But if you moving away from the light source, what happens? It reduces the intensity. What is reducing? Which is the intensity of the light reduces. Similarly, every earthquake also have two parameters. Number one, it is the magnitude of the earthquake, and number two, it is the intensity of the earth. The magnitude of the earthquake is the logarithm to base 10 of the maximum seismic wave amplitude. So it is actually the amount of energy released by the earthquakes. Whatever the energy released, so accordingly it will have one single magnitude, but the intensity will be different. The intensity that represents the how far the earthquake is. If the epicenter, the intensity will be maximum, but when we move away from the epicenter, the intensity reduces. Magnitude of an earthquake, this is a very common term. You must have heard that the Richter scale. Charles F. Richter is a scientist who proposed the magnitude of an earthquake, how much it is 1, 2, 3, 4, 5, 6, 7, 8, or 10. That is based on that the magnitude is given. And based on the intensity, there are two different scales available. One is 10-point scale, that is Rossi-Ferrel scale, and the 12-point scale, that is Mercalli scale. Okay, magnitude is calculated based on the maximum amplification. In this case, this is the, if you see in the screen, what you see here, it is the maximum amplification. And if you take the value of logarithm value of this amplification, how much it happens to the base 10, we will get a number that would be representing the magnitude of that earthquake. This earthquake, if it travels in different locations, depending on from the epicenter, how far it goes, the intensity reduces. So intensity is represented in this scale 1 to 12. 1 means which is not felt except by very few under especially favorable circumstances is called the intensity 1, but intensity 12 means damage the total area and we are able to see the waves which is moving on the surface. So that is a intensity 12.